Hola, hola. ¿Qué tal, amigos? Gracias a ti, Martina, por invitarme. Me encantaría presentar en español, pero no hablo bien español. So I'm going to present in English. So thank you for bearing with me. But yeah, really excited to be here. Thank you guys for having me. So today, I'm going to talk about ZK primitives for privacy applications. And do I have a way to control the slides? Water's good too, thank you. All right. Main goal of the talk today is kind of just give a few examples of, I think, some exciting developments in ZK application development. And when I refer to ZK, I think I broadly mean just like programmable cryptography and just the applications and use cases that are emerging. And I think the message I'm really just trying to send is just like, it's a very exciting time to be in this space. And just like, I guess, quick show of hands, I'm curious who here is a developer in the room? Nice. Who would say they like work on product or want to build a product? Cool. A lot of people. Yeah, very exciting times, guys. For me, at least, it feels kind of like Ethereum or blockchain was a few years ago. My first crypto startup in 2018, which failed miserably, but was essentially like a DEX aggregator. We were building an Ethereum wallet, and I just remember the excitement of being able to plug into decentralized exchanges. It was primarily 0x at the time. I don't think Uniswap was even launched yet, but just like the thrill of like, wow, I can just plug into this open permissionless API and just build something on top of this. And the Lego blocks, as you may have heard us reference to, like that emerged of just like being able to plug into existing applications, really just started to take off over the past few years. And I feel like ZK application development, at least from my perspective, is like similar to that, where the tooling is just getting there. A lot of the primitives, which I'll refer to, just the education, the infrastructure that's available to developers and to builders, is just getting to a place where there's just never been a better time to to get involved, if you're thinking about it. That was a slide I was making right before this talk. So what do I mean by primitives? I'm really not going to try to get into like the low level cryptography and the hash functions and elliptic curves. Like really, I'm just referring to those Lego blocks I was talking about, are like what are existing applications or just libraries that people can plug into today to build some really interesting things. And what I'm going to do is just walk through a couple examples that I think are really interesting and hope to kind of inspire you folks to think of even more things, because it's a wide open space and we're still, exploring this frontier together. So who here is familiar with regular expressions? Fun times. All right. It's basically a string of characters to create a pattern so that you can search and match on strings. And it's like, a pretty simple tool, but it's very powerful, right? It's used all over the place. Here's an example of like a regular expression to grab the domain of an email address, right? So you can use this very simple primitive to do some interesting things. And a team who we help support built this tool, ZK regex. You can probably guess what it does. It does regular expressions with ZK. And it allows you to do some really interesting things, such as like really just, searching through any text input to potential match on strings, with or without revealing some of that input. So if it's really sensitive information, you could see how this might be interesting. And what it essentially does, like you define the regular expression, this library will spin up and generate some CIRCOM code for you, some circuit code to like actually put that into a ZK proof. You can then, put that into other circuits with specific business logic for your application, and use it like any other. And this is kind of just like a quick look through this flow of basically, like taking any arbitrary text input and being able to shove this thing in a ZK proof, compile it, and then be able to, like build an application that generates some proof of some information and a verifying smart contract that on-chain, any EVM compatible chain could verify that this is in fact true. So what might someone do with that basic building block? ZK email, which Santiago actually touched on in the last talk, or a proof of email, is a team that's really been doing some fascinating things with this kind of core primitive. And the problem they arrived at is like, hey, there's a shit ton of Web 2 data out there that's super valuable and full of interesting details about the world and about ourselves. Like, wouldn't it be great to bring that on chain? A big problem is it's tough to verify that information, right? And it's hard to bring that information on chain in a private way. What solutions kind of had developed primarily over the past few years, usually involve like some sort of oracle or a testing party to do this, where they say like, hey, we can attest that this information is true, and we'll post this information on chain for applications or people to use. What ZK email kind of allows is to just like take this information straight from an email and potentially prove something about that email directly on chain. And what that kind of supplies for this Web 2 data is provenance, which again, Santiago talked about, of like, wouldn't it be great if Web 2 service providers just like digitally signed all their information so we could have these assurances that what they say is true, that no one actually manipulated the data before doing so? How could we make it, portable? And maybe most exciting of all is like programmable, of like do arbitrary things with this stuff. And that's what this ZK email project is essentially trying to do. And what they do is, you can see they take an email and take advantage of these like existing internet standards and protocols that already exist, where I think since like 2017, basically email domain servers will take this email and sign it. They'll put an RSA signature on it, which kind of ensures like, the to, the from field, the body of the email, that like is not manipulated and like was in this form when it was sent. So people can't do some, man in the middle manipulation. And what we can do with that is create that into a ZK proof and actually prove that on chain. And that's, I guess, a concrete example of what that looks like. So emails use this DKIM protocol, where they'll basically, like hash and sign all this useful information about an email. And where you might see we're going is like, we could potentially use this like regular expression tool to prove things about that email. And more importantly, like only reveal data that we want to reveal about that. So I think a useful example just to demonstrate, is, proving you control a Twitter account, right? Like how can you port existing social media accounts on chain? By triggering a simple, reset password request, which include the handle that you control, you can basically throw this through ZK email to verify certain things about it, to run a regular expression to extract certain useful information. And again, like put that into a proof that you're verifying in an on-chain transaction. So maybe you're saying like, hey, I want to prove, I control an EthereumArgentina.org email address. Or you're saying, hey, I want to prove I control this specific X account. You could probably imagine a lot of the emails in your inbox being able to prove some really interesting things about that. And what this team eventually realized was like, hey, we can probably like abstract all this logic we've been building for one specific use case into more generalized solution for developers to use and build off. And that's what they've done, and essentially like an SDK where without even a developer having to write specific logic, having to write custom circuits that require, expertise in a specific programming language, that they can start to build useful applications just by grabbing existing tools off the box and changing it to fit some of their needs. And it provides authentication in the sense of like, hey, I control this Ethereum address, and I can prove I also control this email address. And it can do some authorization of like, if there's specific content in the email itself, maybe you want to trigger some action based off that information. And some use cases that this ZK email team has been working on recently is like wallets. Could you control an Ethereum wallet just by using an email address? Could you send payments to people just by sending emails? Account recovery, like adding a signer on a, say, smart contract wallet that's powered by an email address. And yeah, like what are all the kind of email confirmations we receive that might be useful for us to bring into this world of crypto? And if you're curious, yeah, like the team is even giving out grants for people who might want to build some of the many ideas that have been emerging. And to show one concrete example of like, a layer up this stack of ZK primitives, another team separate from ZK email called ZK P2P. Has anyone heard of them before? A couple people, cool. So what ZK P2P is trying to solve is just like the on and off ramping issue of crypto. Like right now, it's pretty hard to do, right? It's not accessible to everyone. There's often high fees involved. You typically need to sign up with some centralized exchange. You need to go through some KYC process to give them your passport or some identification. You don't really know who they're sharing that information with. Maybe selling it, maybe giving it to the government, somewhere in their terms of service that none of us read. So you can see there's some issues generally that they felt like they could improve to try to make this faster, cheaper, and more permissionless, and like less trust on other parties to help us do this. So how do they do this? They basically take existing Web 2 payment services, they grab libraries from the ZK email teams, and they leverage these payment confirmation emails to allow people to onboard and offboard through existing Web 2 services. So what that looks like is basically a peer-to-peer marketplace where someone can escrow their crypto assets in a smart contract. Someone who wants to buy that asset, say maybe I have, USDT, or say I have, I don't know, pesos in Mercado Pago, and I want to get some Ethereum. That buyer could send an off-chain payment to the seller who included some identifier that allows them to be paid on chain. And once they receive a confirmation email, they can actually prove that they paid this amount to this person. And that escrow smart contract can trustlessly verify the contents of that email, like we talked about, and actually unlock those assets. So again, allowing this kind of like less frictionful peer-to-peer marketplace for people to on and offboard from crypto just from using existing payment apps they already use. So I know it started with Venmo, which is payment apps available in the United States. I know there's a handful of currencies and services currently supported. If you guys are interested, maybe you should hop into their Telegram and ask the developers to add Mercado Pago. But just to kind of show, again, like really interesting ways to kind of piggyback off of these existing Web 2 data providers and service providers, where we can take advantage of like basically hijacking their KYC to say, oh, you're already a customer of this service, you can prove it on chain, then you can interact with my application and do really interesting things. So again, just starting with like really simple primitives and libraries that people have been building over time, you can start to see that like teams are able to build these really interesting new novel applications that protect privacy, that do really useful features without actually having to do a whole lot. Like I don't know how big the ZK P2P team is. I think it's less than 5 people. But it's just impressive, again, just like what these building blocks can enable us to do. So that's supposed to be a handshake emoji right there. So taking that Web 2 data and bringing that into Web 3 to do some interesting execution in this blockchain world. Again, bridging that gaps. And like I said, I mean, it's just kind of an open frontier where people are really just discovering interesting use cases as we go, right? There's like a whole shit ton of data in the Web 2 world that we might want to bring into our on-chain lives, but to not have to do it in a very like public way. We can, you know, at times remove intermediaries. And I think email, is just a great example of like, uses some of the most widely adopted web standards in the world, something like, you know, 350 billion emails a day, and just a lot of useful information that people and projects and businesses can take care of. And as you can see, what this kind of like bridging or like merging of Web 2 data, Web 3 execution provides is a couple of things. Like one, compression, right? And like you've probably heard, you know, others even today talk about, right? Like the fact that you can basically do unlimited off-chain computation and then prove that on-chain can be super valuable given just like how slow blockchains are. You know, we mentioned this email example again, like something doing like an RSA signature verification. Right now, that's a computation that it's just too expensive to do on-chain. Like you just run out of gas. But doing that off-chain, submitting a proof is a nice way to get around it. And privacy, you know, the theme of today, allowing people to do selective disclosure where you're saying like, hey, I want to prove some aspect of this email, but I don't want to give you all my information. It allows users to really opt in and understand exactly what they're giving applications information to. Cool. Walking through one more example, bit more high level this time. ZK Kit, a project that's been gaining adoption that essentially, I like to think of it as like Open Zeppelin for ZK. Just like providing reusable libraries for developers to do. Similar to how Open Zeppelin, if you're familiar, just provided a lot of just like well-audited, efficient smart contracts that people could take off the shelf and integrate into their applications. Doing similar things for languages like Circom and Noir, JavaScript, TypeScript, ZK-specific application stuff. That basically allows us to not have to roll our own solutions every single time. So exciting to see, you know, an active community emerging around this, like helping, you know, peer audit, code review, general open source for the win kind of stuff. Here's one example, you know, just doing some math operations. You can grab all these useful functions, utilities, algorithms, data structures right off the shelf and import that into your project. Semaphore is a protocol specifically solving some identity issues. Basically a generic protocol for creating anonymous groups. And I mean, you could think of a lot of interesting examples of like why we might want anonymous groups, right? If you want, your company to have a ability to vote or to have, anonymous feedback, or you want to prove you're an attendee at Ethereum Argentina, but you don't want to have to show any other information other than you bought a ticket. Semaphore provides a lot of that just underlying infrastructure and logic so that developers can build these use cases on top and create anything they might want to do by like, hey, this is just a group of people who have some shared interest. And you could imagine combining that with things like ZK email of like, let's create a group for everyone who has over 1 million Twitter followers, or a group for people who hold this much ETH. I don't know. You could come up with better use cases than I could. But just to demonstrate of like one example is like Semaphore, this protocol that's built for developers to build higher level applications on, uses ZK-Kit under the hood. And one project that uses Semaphore under the hood is an application called Zoopass, which if you went to Ethereum LATAM earlier this year, this was an application used for ticketing. If you plan to go to DevCon, it'll be used there as well. And it's essentially a mobile application for storing like cryptographically signed data. Could be event tickets, could be information about yourself, could be exported information from social media websites. A lot of similar things that I mentioned earlier of like they're helping solve this whole data portability, data provenance area. And it allows users to kind of store information on their own devices and to cryptographically prove information about themselves in a privacy-preserving way. And it uses Semaphore identities for a lot of the group membership stuff it does. So, again, if you go to, if you went to Ethereum LATAM earlier this year, tickets were issued. You could use Zoopass to prove you had a ticket for Ethereum LATAM. As a result, you could join a gated Telegram group where only attendees could interact. You could do some really interesting voting or just, again, like feedback in an anonymous way using these type of foundations. And again, you can see how these blocks start to build on each other. All these projects are open source, public goods. So if you're thinking about hacking at Ethereum Argentina tomorrow, maybe this will give you some inspiration about just some of the ideas you could explore. And again, just kind of explore, what's possible in this emerging frontier. Thank you, guys. I don't know if I have time for questions, but if you do have questions, happy to chat. That's also our PSE Discord, if you're interested. If you are someone interested in building stuff like what I just mentioned, like we help support projects and people. We've supported probably over 100 projects and individuals over the past few years who are like helping push forward this programmable cryptography space. So thanks a lot.